Hi everyone, my name is Yang. I'm from the team Shadow Rail, and in this video, I'm going to talk about our improvement on SimSwap. Before we begin, I would like to introduce our team. So once again, my name is Yang, and this is my teammate Junjie. So what is SimSwap? SimSwap is a deepfake algorithm that takes a face from the source image and replaces the face on the destination image. So it can be used for fun, or it can be used by malicious actor. So this is our goal for our implementation of SimSwap. So our first goal is we want to make it more realistic. We want to make it more realistic in a way that it tricks the human perception to believe that this deepfake is actually real, and it actually crosses the uncanny valley, which plague a lot of common deepfake algorithm out there. And our second improvement is high resolution. The current implementation of SimSwap by the original author only can output a maximum resolution of 224 by 224, making it very unusable. And we have implemented a method to upscale the output resolution so it can be usable on social media on all other platforms. And our third method is that we want to fool a deepfake detector, especially the detector from our opponent's team. So at the end of the day, our deepfake images output by the SimSwap will be indistinguishable by computer and by human. So these are the methods we are going to highlight in this presentation. The first one is augmented dataset. The second one is GFP gun scaling. And the third one is secret method, which I will talk about more in detail later in the video. So let's begin with our first method, which is the augmented dataset. So I've already ran through all the necessary setup above, and I'm going to highlight the actual step for data augmentation. So as you can see on my left side, this is the original dataset. After running the code, we get this directory with a new dataset. As you can see, we have two images over here. One is the normal data, and the second one is the augmented data. So my code basically flips the image horizontally and doubling the dataset basically for free. Why do we do this? So I've analyzed our opponent's detector, and they use facial symmetry as one of the factors to determine fake from real. This is our result. So as you can see from the original dataset, most of it is almost no chance of being real. From our augmented dataset, it's also the same, but there are some slight improvement, which is improvement nonetheless. And now I'm gonna pass to Junjie to talk about GFP gun upscaling.
Okay, thank you, Jaya. So now I'll be covering about generative facial prior generative adversarial network. So for short, it's GFP gun. So basically, what does it do? You can pretend of it as you are redrawing a picture, a very low detail picture. You want to improve it, but instead you have something called a pre-trained facial expert, where it contains dataset of realistic photos of people. Then it will treat you as a guideline for you to improve the picture while keeping it very realistic and also looking upscaled. So basically, the way it works is that you will have a link in between the original photo and also the generative model. And this link, pretended as a bridge, we call it an SFT layer, also known as a spatial feature transform layer. So what does it do is basically, it first extract identity from the original picture by using identity information such as your eyes, your nose, and also your jaw. Then they will start to inject details by putting maybe more pixels into this specific region for your eyes and your jaws and your nose to improve and upscale the quality of the image while also keeping a realistic look by doing adaptive adjustment. So we can have a more upscale image and also a high fidelity image while also keeping it more realistic as we are keeping the original person's identity preserved. So to show you how it works, we first have this SimSwap model. As you can see, we have two inputs here, and we will generate out this output. And as you can see, it's still blurry, and it's not really, there's no clarity into it, right? So now we will improve it by doing the upscaling using the GFP gun here. So we will first clone the repository from GFP gun's GitHub and also inserting it into a folder. Then we will set up the environment for it, and then we will prepare the image over here, which is the LeBron picture just now we have. and also running the JFP gun and having the result over here. And as you can see, visually, you can see there is a big difference where the original photo is blurry and has no clarity, while the upscale version has the opposite features. So to show you more, we actually have the results here. So based on Jingyang's original implementation from SimSwap with augmented dataset, we can see that from SimSwap itself and the augmented dataset being implemented, there is slight improvement for the generated result. However, by implementing JFP gun upscaling, we can see that some of the picture actually have a more higher probability of it being real using the man god detector result. So, for example, you can see the DiCaprio's and Donald Trump's generation. You can see that from 0.0412, it has increased to 0.1901. I would say it's quite a significant result, and compared to other, it's also quite a decent result as there is improvement, right? So now we will be covering the secret method that Jingyang will be explaining it to you guys about. So I'll now pass it to Jingyang.
Thank you, Junjie, for your part. And now I'm going to move on to the secret method. And the secret method is actually noise plus image compression. As you can see, this is the image generated by Junjie, the upscale image. I'm going to take this image and run through this section of the code. And what this code does, it takes in the image, it will add noise with a 5% opacity filter, and then it will run through JPEG compression 5 times. And it will give the output result. As you can see, this is the output result, and it is almost indistinguishable by eye. So let's move on to the result. So this is our result. As you can see, from the GFP gun on the augmented dataset only, we only got around average of highly unlikely to be real. But after applying our offensive method, the p-value quadruple and our classification is improved by a huge margin. I did this for fun. This is the original implementation of SimSwap with 1 million epoch with no GFP gun and no noise plus compression. This is the one after our methods. As you can see, the p-value has increased by a multiples of 7 to 8. The classification is improved by a lot as well. So this actually proves that our combination of our two methods work in tandem with each other to trick the detector and to make the image more realistic to the human eye. These are our references. Before I end this video, on behalf of the team, I would like to thank Professor Raphaël, Team Mangod, which is our opponent team, and the support from our friends. Thank you for watching this video.